Think you know geography? Wait until you hear about places that are gaining land, losing land, and even shifting position on the map. By 2025, seas are disappearing, deserts are spreading, and entire nations are adjusting their borders without war or treaties. These aren't just textbook curiosities, they're changes affecting how millions of people live. From cities that straddle invisible lines to countries wrestling with rising waters, the Earth looks very different than what you remember from school. And in some cases, one city alone shows just how global geography can feel without stepping on a plane. A city split between two continents. In Istanbul, geography shapes daily life in a way few other cities can claim. It is the only metropolis on Earth that exists on two continents, Europe and Asia, divided by the Bosphorus Strait. For locals, commuting might mean taking a bus, train, or ferry, and in the span of minutes, stepping from one continent to another without leaving city limits. The idea sounds almost impossible until you realize that for millions of residents, it's just routine. The Bosphorus itself is far more than a scenic waterway. This narrow strait connects the Black Sea to the Sea of Marmara, and by extension to the Mediterranean. Its role as a maritime highway makes it one of the world's most strategic choke points, with thousands of vessels passing through each year carrying goods, commodities, and energy supplies. Every ship that moves along its waters highlights why the city's location has global economic and political weight, not just local significance. On a more personal level, the geography divides culture as visibly as it divides the land. Wander through a district on the European side, and history presses in from every corner: Ottoman palaces, Byzantine relics, and the remains of empires that once ruled vast territories. Cross over by bridge or ferry, and the rhythm changes. Markets hum with energy, neighborhoods expand with modern construction, and traditions run deep into the heart of daily life. Two ways of living stand side by side, separated only by water, but linked by centuries of shared history. Moving between the two sides is unlike any other commute on the planet. Trains run through underwater tunnels, ferries carve their way across the strait, and thousands of cars travel daily over massive suspension bridges. In most cities, crossing a river means entering another borough. In Istanbul, you change continents in a single crossing. Its geography turned practical, built into the design of everyday routines. Istanbul is a megacity continuing to grow, with its location demanding constant expansion of infrastructure to support a population spread across two continents. Its blend of culture, trade, and strategy proves how maps shape reality more directly than we might expect. And Istanbul is only one example. Sometimes geography can fool the eye entirely, especially when it makes a desert city appear further west than the Pacific coast. The desert city, that's west of Los Angeles. When most people picture the western edge of the United States, Los Angeles usually comes to mind. It sits on the Pacific Ocean, lined with beaches and coastal cliffs, the very image of a West Coast city. So it feels natural to assume Los Angeles lies farther west than any city in Nevada, which is landlocked, mountainous, and arid. But check a map closely, and the result flips that assumption entirely. Reno, an inland desert city, actually sits farther west than Los Angeles. The explanation comes down to the bend in California's coastline. Rather than dropping straight south, the coast angles sharply to the southeast as it nears Mexico. That curve pulls Los Angeles eastward in longitude. Reno, meanwhile, is tucked into the Great Basin, far from the ocean, but positioned on straighter lines of longitude that keep it farther west than LA. The numbers make it clear. Reno sits at about 119.8 degrees west, while Los Angeles is at 118.2 degrees west. That puts Reno roughly 83 miles farther west than the city that fronts the Pacific Ocean. It sounds minor, but longitude is exact, and on this measure, Reno comes out ahead. Maps trick you, longitude matters more than image. This oddity even shows up in the rhythm of the day. Reno often experiences slightly later sunsets than Los Angeles, which surprises anyone who expects the coast to guarantee the last light. Locals sometimes take pride in pointing this out, turning their supposed inland disadvantage into a playful boast that their desert sunsets outlast LA's coastal ones. It's a reminder that geography refuses to follow the neat patterns we imagine. Coastlines bend, land shifts, and assumptions fall apart when faced with precise coordinates. What seems obvious on first glance doesn't always hold up under closer measurement. And just as land placement can surprise us in the deserts of Nevada, massive changes can also happen in the frozen extremes of the planet, changes that defy expectation in an entirely different way. Antarctica grows in size. We often hear reports of Antarctica shrinking, glaciers retreating, ice sheets thinning, and shelves breaking into the sea. But the picture isn't always so straightforward. Some edges of the continent temporarily press outward, forming thicker shelves that give the appearance of surface growth. At the same time, though, long-term satellite records show the continent as a whole is losing mass on a massive scale, measured in billions of tons each year. Both things happen at once: localized gains and continent-wide decline. That contrast comes from how Antarctica works as a system. The land beneath is draped in ice, so thick it holds about 90% of Earth's freshwater. Where glaciers meet the ocean, huge floating platforms called ice shelves push outward. Unlike seasonal sea ice that freezes and melts in place, these shelves are extensions of land ice moving slowly into surrounding waters. If they expand, they don't immediately raise sea levels. But if they fracture and collapse, the glaciers feeding them accelerate, and that melt does contribute to sea rise. Expansion can be a signal of stress just as much as it can look like growth. The bigger picture is clear. NASA and other agencies have shown that Antarctica has lost trillions of tons of ice since the 1990s. That translates to roughly 1 millimeter a year of added sea level rise, making Antarctica responsible for about a third of the global annual increase. Even when certain shelves advance for a period, the continent overall continues to hollow out, shedding weight from its interior while surface outlines shift around the edges. Understanding these changes matters far beyond the southern pole. The system is dynamic, with cracks opening in some places while shelves spread in others, but the long-term direction points toward loss. The rate of global sea level rise has already doubled over the past century, and Antarctica's changes are a major piece of that acceleration. What makes this even more striking is how it contrasts with other parts of the world. While Antarctica's outlines may sometimes extend outward, yet mask a deeper depletion, there are places elsewhere where land is being added each year in the opposite direction, expanding naturally even in the face of rising seas. A country that grows every year without war. Most countries threatened by rising seas are losing coastlines, but Bangladesh is one of the few that sees land appear year after year. Without moving a border post or signing a treaty, the country is expanding naturally. This growth comes from the great river systems that run through it, chiefly the Ganges and the Brahmaputra. Carrying immense volumes of sediment down from the Himalayas, these rivers spread into a vast delta where the silt is deposited. Over time, those deposits build up into new surfaces, some of them evolving into permanent land. It is a form of quiet expansion, playing out on riverbanks and coastal edges where the landscape seems to redraw itself season after season. These new areas are known locally as chars. Some chars are fleeting, vanishing with the next round of floods, or being reshaped by strong currents during the monsoon. Others endure, stabilizing long enough to be used by communities. Farmers quickly adapt, planting rice, vegetables, and laying claim to fresh grazing plots within months of the land's formation. From above, the delta resembles a living patchwork of shifting ground, temporary islands rising, green shoots of farmland taking hold, and braided channels adjusting their routes. It is rare to see a nation gain territory this way, highlighting just how unusual Bangladesh's situation is compared with many island and coastal states that steadily lose land to the ocean. The paradox is that Bangladesh is expanding and eroding at the same time. Rising seas continue to threaten villages and farmland nearer to the coast, where saltwater intrusion displaces residents and undermines agriculture. Yet upstream, sediment deposits create ground that can sustain life, offsetting some of what is lost further south. Reports from the United Nations and World Bank underscore this tension. The country experiences both gains and losses, sometimes in the same season, leaving its geography in constant negotiation with the forces of climate and water. For a nation with more than 175 million people packed into one of the most densely populated regions on Earth, every acre of new land matters. Each patch supports families, strengthens food production, and offers rough balance against the pressure of encroaching seas. Bangladesh illustrates how geography can quietly and continually reshape a country's outline. And while its transformation shows the power of rivers to redraw borders, another example lies in sheer size, an immense nation where geography is measured not by acres gained, but by the struggle of living across countless time zones at once. The country that controls 11 time zones. Russia is the rare example of a country where geography doesn't just shape borders, it shapes time itself. It remains the only nation on Earth that spans 11 time zones, stretching across 1/8 of the planet's land area. At any given moment, different regions of the country occupy entirely different points on the daily clock. Morning, afternoon, and night all exist at once within its borders. The contrast is sharp when you look at two edges of the map. In Kaliningrad by the Baltic Sea, a workday may be beginning at sunrise. Meanwhile, across the Bering Strait in Chukotka, people are winding down for sleep. That's nearly half a day of difference within the same country's borders. For many Russians, even a simple phone call to relatives several regions away can feel like international communication, because the hours often don't line up at all. This time spread is not just a trivia point, it carries real effects on daily life and national operations. Businesses and government agencies must constantly adjust schedules to bridge hours that rarely overlap. Airlines crossing Russia can spend 8 or 9 hours in the air without ever leaving Russian skies, moving gradually through those shifting time boundaries. The iconic Trans-Siberian Railway journeys across nearly a week of changing clocks before reaching its eastern destination. Ordinary commuters, travelers, and workers learn to navigate time the way others navigate distance. Comparisons highlight how unusual this is. The United States, often thought of as immense, covers only 4 main time zones on the mainland. Russia's 11 reveal scale on an entirely different level, demanding that its infrastructure, communications, and even personal routines operate with a constant awareness of time's uneven spread. It is a daily reminder that geography doesn't only stretch space, but also warps perception of time itself. Living there means recognizing that your day is just one version of countless others unfolding inside the same national borders. The experience makes Russia feel like a condensed version of the globe, where human activity cannot possibly sink from one end to the other. But if time zones represent one extreme of geography's impact, the opposite problem appears elsewhere, where the issue is space itself vanishing faster than people can adapt. A sea that's disappearing fast. Visit the Dead Sea today, and the shoreline is not where you expect it to be. Over recent decades, the waters have been shrinking at a pace so visible that walking to the edge means crossing wide stretches of land that were once underwater. Each year the basin retreats further, turning familiar coastlines into dry ground and leaving behind a reminder of how quickly a landscape can change. The Dead Sea occupies a unique place in geography and science. Sitting more than 1,300 feet below sea level, it is the lowest exposed point on Earth. Its waters are also some of the saltiest on the planet, holding concentrations nearly 10 times higher than most oceans. Those conditions create the famous experience of floating with ease, attracting travelers who come to test the buoyancy and cover themselves with mineral-rich mud. The bright salt crusts along the shore sparkle in the sun, yet underneath the spectacle lies an environmental crisis that may end this phenomenon within a few decades. Scientists warn that if the present decline continues unchecked, the Dead Sea could all but disappear around mid-century. The reasons are well known. Natural evaporation in a desert climate combined with human diversion of water from the Jordan River and surrounding tributaries, which once refreshed the basin. With less inflow and relentless summer heat, balance tips toward loss. The receding shoreline is not merely a shift in scenery, but a disruption of a system that took millions of years to form. That disruption goes beyond the water's edge. As the sea level falls, hidden salt layers underground begin to dissolve, leaving cavities that collapse into sudden sinkholes. These openings have destroyed farms, highways, and even tourist facilities. Entire stretches of coast are now scattered with dangerous craters, changing the region from a vibrant resort area into an unpredictable hazard zone. The crisis also spills over into politics and economics. Israel, Jordan, and Palestine all border the Dead Sea and depend on its resources, yet efforts to save it are complicated by competing needs for freshwater and the difficulty of large-scale restoration projects. Tourism, a vital economic driver, faces steep decline as access points shift and safety risks increase. What was long seen as an eternal sea is proving vulnerable, a natural wonder slipping toward memory. Other places, however, tell a very different story, not of vanishing land, but of expansion, where coastlines have been deliberately pushed outward to create something entirely new. The country that expanded by 25%. Some countries manage vanishing coastlines, but Singapore has taken the opposite approach. Since the 1960s, this small nation has reshaped itself through land reclamation, steadily adding to its territory in a way few places have achieved. Maps from independence, compared to those today, reveal a striking difference. Entire stretches of coastline didn't exist back then, but now support vital infrastructure and daily life. The method may sound simple in concept, yet requires massive engineering. By layering sand, rock, and engineered fill into nearby waters, Singapore has built new patches of land where none existed before. In a nation where every square kilometer counts, these gains carry significant weight. Some of the country's most important sites now sit on reclaimed ground. Changi Airport, one of the busiest global hubs, operates largely on land created by reclamation, handling tens of millions of travelers every year. New harbors, industrial areas, and residential neighborhoods also rise on space that used to be open water. For a territory smaller than many world cities, this expansion has been essential. Without room to naturally spread, Singapore's only option has been to build its own foundation. Reclaimed land is not left as empty space. It is immediately put to use as housing estates, industrial parks, and recreation zones for a population nearing 6 million. In effect, engineering has given the city-state the ability to compete economically while avoiding the limitations of its geography. The land created is deliberate, planned, and packed with purpose. What makes Singapore's expansion unique is that it is peaceful. Most historical map changes came through conquests or disputes, yet Singapore's borders grew through construction, not conflict. There were no battles to fight, only machines and engineers steadily redrawing the nation's edge. This transformation shows that geography can be negotiated by human choice rather than by accident or force. It is a clear example of adaptation in the face of natural limits. Today, Singapore's coastline looks nothing like it did half a century ago, proving that growth can be engineered rather than conquered. But while this city-state has expanded its footprint on the map, the other extreme exists as well, where a whole recognized country is so small that it can be compared to the size of a simple city park. The world's smallest country versus a city park. You might picture Central Park in New York as just an urban escape tucked between skyscrapers, but when measured against the world's smallest country, its scale becomes astonishing. Central Park covers far more land than Vatican City, reminding us that what seems modest in one place can utterly outsize an independent nation in another. An area most visitors stroll through in a single afternoon surpasses the entire territory of the Catholic Church's center of power and one of Europe's most historic states. Vatican City is recognized as the smallest country in existence, occupying only about 0.2 square miles. To put that in context, the entire country could fit inside Central Park many times over. From above, its outline appears more like a district within Rome than a state of its own. Yet the Vatican operates independently with borders, sovereignty, and functions that rival much larger nations. Passing from Rome into Vatican territory isn't just a change of neighborhood. It is a shift across an international boundary that plays out in just a few steps. The Vatican's position as a sovereign state was secured in 1929 through the Lateran Treaty. Since then, it has acted with full independence, maintaining its own embassies, currency, postage, and security forces. Its Swiss Guard, with centuries of tradition, is one of the oldest active military units in the world. All of this emphasizes that Vatican City is not symbolic independence, it is tangible governance. Its population may only number in the hundreds, but its influence stretches to billions across the globe through religion, diplomacy, and culture. Despite its limited size, Vatican City attracts millions of visitors each year. Tourists come to witness the splendor of St. Peter's Basilica, the treasures of the Vatican museums, and the artistry of the Sistine Chapel. In mere moments, they pass from Italy into another nation entirely, yet many may not reflect on the extraordinary reality of entering the world's smallest country. Here, geography turns expectations upside down. A park designed for leisure in New York vastly outpaces it in scale, but the Vatican demonstrates how power, history, and identity can transcend physical boundaries. And while this example shows influence built within the smallest of footprints, other landscapes reveal the opposite. Territories where size is measured in vast natural abundance, defined not by land, but by water. The country of 2 million lakes. Canada's geography is defined less by its land than by its water. No other country on Earth contains as many lakes, and by a wide margin. These lakes stretch across forests, plains, and tundra, forming an aquatic landscape that influences everything from the environment to daily life. For Canada, freshwater isn't just a resource, it is the backbone of its national identity. By 2025, advances in satellite mapping and geographic information systems have made it easier to confirm what was long understood. Canada holds the majority of the world's freshwater lakes. More than 60% of all such lakes lie within its borders. They range from countless smaller pools scattered across boreal wilderness to immense inland seas like Lake Superior, which alone dwarfs many entire nations in size. The result is a country whose physical shape, ecosystems, and culture are tied indelibly to water. These lakes' moderate climate, by cooling summers and softening winter extremes, creating regional weather patterns that ripple far beyond their shores. They provide the source of rivers that sustain farmland, feed hydroelectric systems, and supply drinking water to cities across the country. Animal habitats depend on their rhythms, with fish, birds, and mammals adapted to an environment where water is woven into the landscape at every turn. For indigenous communities, lakes are not just natural features, but living parts of cultural knowledge, spirituality, and subsistence. Generations have traveled, fished, and built their identity from the networks of lakes that shape the land. Tourism is equally tied to these waters. Every summer, Canadians migrate to cottage country to fish, paddle, and swim. International visitors are drawn to the vastness of the Great Lakes, some of the busiest freshwater shipping routes in the world, while inland vacations revolve around smaller lakes that dot the forests like mirrored fragments of sky. From recreation to trade, the presence of lakes sustains a wide spectrum of social and economic activity. Canada's dominance in freshwater makes it unique, a modern nation whose landscape is defined less by soil and rock than by its unmatched reservoir of water. Yet while one part of the planet contains more freshwater than anywhere else, another faces the opposite challenge, regions where even the soil itself is steadily giving way to something far less forgiving. The expanding desert giant. Every year, more of Africa's landscape finds itself overtaken, not by the ocean, but by sand. The Sahara Desert, already the world's largest hot desert, is steadily expanding. Its southern edge pushes into farmland and pastures, turning once productive soil into arid ground. Families who have worked the same fields for generations now watch them disappear beneath dunes that stretch beyond eyesight. What once grew crops or supported herds turns barren, forcing thousands to move farther south in search of water and arable land. Today, the Sahara spans nearly one-third of the African continent, and climate shifts make its reach grow. Prolonged droughts, shorter rainy seasons, and rising temperatures accelerate desertification, robbing the soil of its fertility. This expansion is not a distant trend, but an ongoing upheaval measured in disrupted harvests, failed grazing routes, and villages left behind. For people already living along the fragile divide between desert and savanna, The loss of even a narrow strip of land can decide whether they hold on or are forced to move. In countries such as Niger, Chad, and Mali, the changes carve directly into daily life. Cropland shrinks, grazing routes used by pastoral families vanish, and settlements succumb to shifting dunes. Nomadic communities, long accustomed to moving with the seasons, now face deserts where pasture once existed, leaving them with fewer options to sustain their animals or their way of life. Across the region, migration has become the reality, families moving southward in hopes of reaching land that can support crops, or resettling in growing towns where farmland is no longer an option. To push back, governments and international groups turn to ambitious initiatives. The most notable is the Great Green Wall, led by the African Union. Intended to stretch nearly 5,000 miles across the continent, it aims to build a wide belt of vegetation from Senegal to Djibouti. Through reforestation, agroforestry, and land restoration, the project seeks not only to anchor soil, but also to restore livelihoods for millions. Farmers are being trained in sustainable practices designed to resist drought, while local efforts expand tree planting and water capture systems. Despite these efforts, the Sahara remains a shifting force, its slow advance visible at the edges of villages, farms, and roads, where the sand continues pressing forward. This is geography not as an abstract map feature, but as a force that reshapes where and how people live. And in other parts of the world, humanity contends with a completely different challenge. What happens when land is crowded so tightly that every street feels like a world unto itself? The most crowded nation on Earth. When people think of the most crowded places, they often picture megacities like New York, Hong Kong, or Mumbai, where millions live in dense clusters of towers and streets. Yet these global cities feel almost open compared to an entire nation that surpasses them all in population density, Monaco. This principality on the Mediterranean coast is the most densely populated country on Earth. Its entire territory spans less than 1 square mile, and within that tiny footprint live tens of thousands of residents, far more per square mile than even the busiest urban centers elsewhere. Monaco is pressed against the sea on one side and the French border on the other, leaving no room for outward growth. The only option has been to use every available space to its limits. Apartment blocks rise directly along the waterfront, towers crowd together on steep hillsides, and reclaimed land extends the shoreline in calculated stages. Even the rooftops serve double duty as gardens, pools, and terraces, compensating for the lack of open ground. Where other countries spread their populations across wide areas, Monaco layers its people vertically above the same narrow strip of coast. This density has not diminished Monaco's status. It has become central to its identity. The principality functions as a glamorous hub of European life, a magnet for global finance, luxury tourism, and cultural events. Institutions like the Monaco Grand Prix turn its streets into international spectacles. Residents and visitors alike move through neighborhoods where nearly every building houses some form of business, leisure, or residence. Walking across the entire country takes only minutes, yet inside that space are banking centers, luxury boutiques, and concert halls that rival those of major world cities. Monaco's success lies in its ability to turn constraint into opportunity. Its population density, while extreme, does not signal collapse but adaptation, a country operating at the limits of geography while sustaining one of the highest qualities of life anywhere. This contrast reshapes how density is understood. What looks impossible, living at such concentration, becomes not just feasible but highly desired. But while Monaco shows how a nation can pack more into less space, in other parts of the world, the defining feature is not too many people squeezed onto a small landmass, but instead the opposite. Vast landscapes losing ground as ice and land literally disappear into the sea. An island that's melting away. Greenland holds the world's second largest ice sheet, a frozen mass that blankets a land area bigger than most countries. For thousands of years, it has acted as a reservoir of water, helping regulate the planet's climate. Today, that frozen shield is unraveling. Each year, Greenland is losing about 280 billion tons of ice, a pace confirmed by NASA's long-term satellite data. This staggering loss is one of the strongest signals of climate change in action. What might seem abstract translates into concrete, measurable consequences for the rest of the world. The connection becomes clear in rising seas. Meltwater from Greenland does not stay local. It flows into the global ocean. Since the early 1990s, the rate of sea level rise has doubled compared to most of the 20th century, climbing from about 1.7 millimeters per year to roughly 3.2 millimeters annually. Greenland's melt is a primary driver of this acceleration. Even small increases add up. An extra inch or two of water spread across every shoreline is enough to bring more frequent flooding, stronger storm surges, and higher erosion risks to millions of people living near the coast. Closer to the ice sheet, the transformation is impossible to miss. Glaciers are pulling back by kilometers within a single generation. Valleys once locked in ice for millennia now reveal bare rock and open water. Each summer, melt seasons lengthen while winters rebuild less than before. The land itself seems to be emerging from under the ice, while the glaciers that once shaped it stream outward as runoff. For Greenland, stability has been replaced by movement, a massive system shifting into the ocean day after day. Scientists warn that the danger is not only in the loss itself, but in feedback loops. As ice shrinks, dark rock absorbs more sunlight, driving warming and causing even more rapid melt. Once these feedbacks gain momentum, reversing them becomes almost impossible. While the complete collapse of Greenland's ice sheet would push global seas 6 meters higher, the steady, year-to-year decline already underway is changing coastlines in real time. Greenland's slow draining of ice is a reminder that Earth's most dramatic shifts often unfold steadily, reshaping maps with persistence rather than sudden collapse. And in other corners of the planet, another kind of force works just as relentlessly, not through melting, but through the constant cracking and burning that marks the restless ground beneath our feet. Where Earth cracks and burns most. Draw a line around the Pacific Rim and you trace one of Earth's most restless zones, the Ring of Fire. This 40,000 kilometer arc holds about 3/4 of the world's active volcanoes and is where earthquakes strike with relentless frequency. From island chains to mountain ranges, it's the single most concentrated band of tectonic activity on the planet. In short, it's where Earth's crust refuses to stay still. The belt stretches across astonishing landscapes. In Japan, snow-capped Mount Fuji sits at the heart of a fault-ridden island chain. Along the western rim, the Philippines rise directly above unstable seams of the seabed. On the eastern edge, the Andes stand as a towering reminder of oceanic plates sinking beneath South America. Chile alone sits on dozens of active volcanic sites, each tied to the ongoing collision of massive slabs of rock beneath its length. Every peak and trench illustrates the same fact. Life on the Ring of Fire is defined by constant geological tension. By 2025, monitoring systems continue to measure steady activity across the zone. Volcanic clusters, earthquake swarms, and tremors rarely stop, even if many of the events remain small. Sensors register pulses of energy deep underground that rarely make the news but point to vast pressure locked beneath the crust. For people living there, these signals are not abstract. They serve as reminders that eruptions, quakes, and tsunamis are an ever-present possibility. What makes the Ring of Fire even more critical is the scale of communities built directly on it. Megacities like Tokyo, Manila, and Jakarta sit squarely in hazard zones, housing tens of millions of residents within reach of active volcanoes and fault lines. People remain because the benefits are undeniable. Fertile volcanic soils produce crops, coastlines provide shipping routes, and mineral-rich terrain supports entire industries. Opportunity and risk are fused together, making life along the Ring of Fire both precarious and productive. This balance is fragile. The same tectonic forces that enrich soil also shake cities, and the same seas that fuel trade can deliver tsunamis in a matter of hours. The Ring of Fire shows how geography can define human life more powerfully than borders ever could. And while here the ground itself is unstable, other parts of the planet reveal equally striking stories hidden not in fire, but in water held in remarkable concentration. The world's deepest freshwater treasury. Deep in Siberia, lies one of the planet's most important natural reservoirs, Lake Baikal. Often called the Pearl of Siberia, it holds one of the largest single reserves of unfrozen freshwater on Earth and also claims the title of the deepest lake, plunging more than 5,300 feet. This immense depth makes it a global treasury of freshwater, unmatched in scale and importance. Few people may ever see it firsthand, but Baikal is a resource on which much of the world's balance quietly depends. Its records do not end with depth. Baikal is also among the oldest lakes known to science, with origins stretching back at least 25 million years. While empires rose and fell across Eurasia, Baikal remained in place, collecting sediments and fostering life across unimaginably long spans of time. This enormous age has given the lake the rare ability to preserve ecosystems over evolutionary timescales, offering scientists clues about how species adapt and survive under changing conditions. Over that timeline, Baikal developed a biodiversity found nowhere else. More than half the species in its waters exist only within its basin. The Baikal seal, or Nerpa, is the world's only exclusively freshwater seal. Fish such as the oilfish and unique forms of crustaceans fill its depths, while microscopic organisms support the food web in specialized layers shaped by depth, temperature, and oxygen content. For researchers, Baikal functions as a natural laboratory, an aquatic world where evolution played out in isolation, protected by geography and the self-contained nature of its basin. Yet even here, threats are building. Rising water temperatures stress ecosystems finely tuned to stability, while algal blooms tied to warmer conditions disrupt oxygen levels and alter the food chain. Added to that, pollution from development and industry seeps into places once considered remote. By 2025, new conservation and monitoring programs track these changes more closely, though scientists warn that a lake stabilized over millions of years can still be unsettled in only a few decades. For local communities, Baikal is more than water. It is sacred ground, bound to cultural traditions and histories that treat the lake with reverence. For humanity as a whole, it is an irreplaceable storehouse of knowledge and resources. It stands as proof that Earth's freshwater reserves can be as deep and dramatic as any mountain is high, a reminder of extremes that shape our planet in ways we cannot ignore. And while this is the deepest treasury of freshwater, elsewhere another measure of depth pushes far beyond any lake, plunging to the most extreme depths known anywhere on Earth. Earth's deepest point outclasses Everest. Mount Everest is often used as the ultimate measure of Earth's extremes, standing just shy of 29,000 feet above sea level. Yet the highest peak is outclassed by what lies beneath the Pacific Ocean. The Mariana Trench holds the Challenger deep, plunging to nearly 36,000 feet. Put Everest inside, and its summit would still remain far below the surface. In raw scale, this depth goes thousands of feet beyond the tallest mountain's height. The magnitude is striking, but the conditions make it remarkable. At the bottom of Challenger Deep, pressure exceeds 1,000 times what we feel at sea level, enough to crush ordinary vessels instantly. This lightless, near-freezing environment was once assumed to be sterile, devoid of life. Instead, exploration has revealed the opposite. Scientists have found bacteria, extremophiles, and even small organisms adapted to endure the crushing weight of water. These species survive on chemical energy rather than sunlight, extracting nourishment from elements such as methane or sulfur. Their existence proves that life can persist under conditions previously thought impossible, forcing us to rethink what environments might sustain biology on other worlds. If creatures thrive in the trench without light, similar ecosystems might exist beneath the icy oceans of moons like Europa or Enceladus. Despite these discoveries, reaching the bottom remains rare. Only a handful of manned submersibles have descended all the way down, joining unmanned probes in probing the trench's floor. Each dive collects samples and data that expand our understanding of how geology and biology interact under extremes of pressure and isolation. The trench is not just another geographic statistic. It is proof that Earth's extremes are as much about hidden depth as towering height. What Challenger Deep illustrates is that the planet's grandest records need not always point upward. Sometimes, they point into darkness, where scale and survival rewrite assumptions. These deep points remind us that Earth's geography holds constant surprises, shaping how we think about both land and sea. And from these hidden depths, our focus shifts to another frontier, one where surprising closeness challenges the distances we imagine between nations. One state closer to Russia than America. The United States and Russia might seem like continents apart, but in reality, they share one of the planet's closest borders. From the edge of Alaska's western coast, Russia lies just across the Bering Strait, less than 55 miles away. On clear days, the Russian shoreline can actually be seen from American soil. What often feels like a rivalry defined by distance is, in fact, separated by little more than a narrow stretch of water. At the center of this strait sit the Geomed Islands, a striking example of this closeness. Big Geomed belongs to Russia, while Little Geomed belongs to the United States. Only 2.4 miles, or about 3.8 kilometers, separate them. Standing on one, it is easy to spot the landforms and even structures on the other. Yet the water between them is more than a geographic divide, it is a leap in time. Big Geomed sits nearly 21 hours ahead of its neighbor, meaning that gazing across the channel from the US side is like looking into the next day. Few places on Earth condense both space and time separation into such a small distance. Alaska highlights this paradox more than anywhere else. For most Americans, the state feels remote and far-flung, but its far western edges sit closer to Russian territory than to much of the continental United States. A flight from Anchorage to Seattle covers more ground than the water that separates Alaska from Siberia. It looks like the edge of America on most maps, but in practical terms, it is one of its closest points of contact with another major power. This slim distance has long carried geopolitical weight. During the Cold War, the Bering Strait bristled with monitoring stations, radar systems, and military watchpoints, as both nations tracked activity across the border. Today, the region still matters, not only for security, but also as a potential gateway for Arctic shipping routes and resource exploration. Its position between the Pacific and Arctic Oceans ensures that it remains strategically significant, even without a bridge or road to connect the two sides. Geography makes rivals into neighbors, and the line drawn down the middle of this narrow strait is enough to separate two of the world's largest nations. But borders do not always divide so sharply. In some parts of the world, one single waterway does the opposite, linking multiple nations together through a shared and fragile lifeline. The river connecting 11 nations. The Nile River stands apart as the only waterway that links more than 10 nations together under one system. Stretching over 4,100 miles through Africa, it is not just the longest river on Earth, but also one of the most politically significant. By 2025, the Nile Basin supports upwards of 10 countries across Northeast and East Africa, each relying on its waters for farming, fishing, and electricity. This makes the river more than a natural feature. It is a foundation of national security for millions of people. For thousands of years, the Nile has carried immense weight in human history. Ancient civilizations thrived on its seasonal floods, and today its flow still underpins food security and economic survival. But the pressures on it are greater than ever. Rapidly growing populations, shifting rainfall brought on by climate change, and the intensifying needs of modern economies all converge along this same river. Managing those demands across multiple governments, each with its own interests, turns the Nile into one of the most complex shared resources on the planet. The Grand Ethiopian Renaissance Dam is the clearest example of both opportunity and strain. Built in Ethiopia to generate hydroelectric power, it symbolizes progress and energy independence for millions. But downstream nations such as Sudan and Egypt worry about reduced river flow, especially during periods of drought. For them, any alteration to established water patterns threatens agriculture, industry, and access to drinking water. Disagreements over how to manage the dam show how deeply one decision in a single country can ripple across the entire basin. This is the Nile's paradox. It sustains farmers who depend on predictable irrigation, fishing communities who draw their livelihoods from its currents, and national grids that rely on consistent electricity. Yet because it must do so across so many borders, every negotiation becomes a balancing act between cooperation and conflict. When the river rises, it carries hope and productivity. When the flow changes unexpectedly, it risks inflaming disputes. The Nile demonstrates how geography binds together vast regions while straining them at the same time. A river this vital proves that even features that look steady on a map are dynamic, shifting the lives of nations around them. And sometimes, what appears immovable, like an entire landmass, turns out to be slowly on the move after all. An entire continent on the move. Australia is one of the rare places where you can measure continental motion with modern tools. Each year, the landmass shifts northeast at roughly 2.7 inches, carried on the slow but steady movement of the Indo-Australian tectonic plate. It is not something you feel standing still on the ground, but across decades, that drift becomes significant, shifting the country several feet from its earlier position. This migration creates practical consequences. Systems that rely on precise location data, such as GPS, construction surveying, and agricultural planning, cannot ignore even small changes. By 2025, the cumulative drift forced Australia's mapping authorities to adjust the nation's official coordinates so that satellite positioning lined up with reality. Without these corrections, a self-driving tractor guided by GPS might plow in the wrong lane, or engineering projects would risk measurement errors. Something as seemingly abstract as continental drift becomes part of the daily infrastructure of technology. The phenomenon also underscores the restless nature of Earth's crust. Australia lies away from the fault zones that define the Ring of Fire, placing it among the most geologically stable regions on the planet. Yet its steady northeastward journey shows that stable does not mean fixed. The surface beneath towns, airports, and highways moves continuously, even if the changes remain invisible to those living there. Technology companies and government agencies alike account for this motion. Updates to mapping software reflect positional changes, ensuring consistency for everything from car navigation apps to precision agriculture. Research institutions use the data to refine models of tectonic dynamics, learning how continental plates interact on a global scale. What might feel like motion too small to notice is enormous when applied over the span of an entire continent. In contrast to the dramatic eruptions and earthquakes that dominate headlines, Australia's drift is quiet, uniform, and predictable. Yet it demonstrates the same principle. Our planet's surface is never fixed in place. The land beneath us changes position at a pace we cannot sense, but cannot ignore, linking natural processes to the technologies we rely on. And while continents shift on hidden plates, other parts of the world remind us that geography's surprises can also be counted one fragment at a time. The land of islands without end. Finland is not usually the first place people think of when they imagine endless chains of islands. Yet this northern nation quietly holds one of geography's biggest surprises. Finland is home to an extraordinarily large number of islands, far more than almost any other country. Its terrain is among the most island-dense on Earth, shaped into a fractured patchwork of water and land that makes its national map distinctive worldwide. What makes Finland stand out is the scale. It holds dramatically more islands than its Scandinavian neighbors and even surpasses countries better known for vast archipelagos. Indonesia, often recognized globally for its sprawling island chains across the equator, has fewer than Finland when measured by the same criteria. The difference highlights how geographic assumptions can be misleading. Where Indonesia's islands rise from tropical seas, Finland's were carved by glaciers during the last ice age, leaving behind rocky fragments and waterways across northern latitudes. The result is a jagged coast and inland terrain broken into tens of thousands of pieces. This fragmented setting shapes how people live and move. The waterways that thread between islands form natural channels, functioning as highways for fishing, transport, and recreation. In summer, families head to cabins tucked along lake islands, or remote coastal inlets, cementing one of Finland's strongest cultural traditions, the seasonal retreat to nature. Tourism builds on the same appeal, with visitors drawn to the experience of boating through the archipelago and stepping ashore on secluded islands. Infrastructure also reflects this unusual geography. Ferries carry cars and people across key straits, bridges link smaller gaps, and many communities remain accessible only by watercraft. For travelers, moving through Finland often feels like weaving a path through a giant puzzle, where every turn opens onto another body of water dotted with forested islands. This interconnectedness between land and water influences daily routines in ways that are rare elsewhere. Despite not advertising itself as the world's island nation, Finland effectively holds that title. It is a landscape defined by fragments, where nature broke the land into scattered pieces and people adapted by building lives among them. But while Finland demonstrates how abundance of land and water can coexist in balance, another region of Earth illustrates geography's influence on a far larger scale, an environment that sustains life everywhere with the air it produces. The planet's green lungs. The Amazon rainforest is often described as the lungs of the planet, but its role is far more complex than a single metaphor suggests. Covering millions of square miles in South America, it is globally critical, massive in size, unmatched in biodiversity, and central to regulating the Earth's carbon and climate systems. While plants in the Amazon do release oxygen through photosynthesis, much of that oxygen is consumed again by natural decomposition and respiration. Its deeper importance lies in absorbing carbon dioxide, stabilizing weather patterns, and supporting an interconnected web of life across the basin. That balance is increasingly fragile. Logging, agriculture, and uncontrolled fires strip away vast areas of forest each year. When trees are cut or burned, the carbon they store escapes directly into the atmosphere, weakening the Amazon's role as a carbon sink and speeding global warming. Scientists caution that if deforestation continues at its current pace, the forest's ability to regulate rainfall and keep regional climates steady may falter. What should act as a safeguard against rising greenhouse gases instead risks becoming a major source of them. The biological richness of the Amazon adds immeasurable weight to its influence. It is home to millions of species of insects, mammals, birds, and plants, many of which exist nowhere else on Earth. This biodiversity underpins the stability of the forest. Every tree and animal occupies a role in maintaining balance, from soil health to pollination. Remove too many of these links, and the system begins to break down. Habitat loss is not just a local problem. It undermines one of the most critical ecological anchors of the planet. The water network amplifies the Amazon's significance. The Amazon River discharges more water than any other river on Earth, carrying sediments and moisture that tie the rainforest tightly into global cycles. This immense river system influences rainfall across South America and even contributes to weather patterns as far away as Africa. Each shift, trees dying, rivers redirected, storms altered, demonstrates how integral the rainforest is to planetary systems that extend far beyond its boundaries. The Amazon shows how a single region can act as a regulator for the entire Earth, shaping air, water, and climate. But geography's power is not always tied to vast spans of land. In other places, it is revealed through countless smaller features packed into a compact landscape, where water defines identity just as forcefully as forests do here. A country dotted by thousands of lakes. Switzerland is often imagined as a country of peaks and glaciers, but its other defining feature lies in its water. Within its compact territory are thousands of lakes, a concentration that makes freshwater as central to the Swiss landscape as mountains. For a nation that measures only about 16,000 square miles, this density is extraordinary. Nearly every valley or basin shelters a blue expanse, and together they give the country a second identity, one defined by reflection and flow rather than elevation. The origin of these lakes comes from ice rather than age-old rivers. Across repeated ice ages, glaciers advanced and retreated, their immense weight carving valleys and deep basins into the land. When the climate warmed and the glaciers receded, meltwater filled the depressions they left behind. Today, those waters range from small alpine ponds high on the slopes to vast bodies like Lake Geneva and Lake Constance, whose surfaces stretch across regions and even cross international borders. They are striking reminders of how glaciers reshaped Central Europe, leaving thousands of liquid signatures in the terrain. Famous names such as Geneva, Lucerne, and Constance dominate images of Switzerland abroad, their mirrored waters doubling the view of snowy summits above them. Tourism flourishes around their shores, with visitors sailing, hiking, or simply standing still to watch mountains reflected in glassy water. Local economies rely on this steady flow of visitors, as towns and cities have long built their livelihoods around lakeside beauty as much as alpine panoramas. But these features are not purely scenic. Switzerland generates much of its renewable electricity through hydropower, with plants linked directly to its lakes and reservoirs. The elevation and steady runoff from glaciers and rain supply the flow needed to power homes, trains, and industries. These waters anchor ecosystems as well, creating habitats for fish, waterbirds, and forests that thrive around their edges. Protecting the lakes means preserving both the stability of energy and the health of the environment. For a landlocked country, Switzerland offers something unexpected, an identity written as much in water as in stone. Its countless lakes are proof that glacial history can shape a nation's future just as strongly as its mountains. Yet, while Switzerland thrives with abundance, another country shows what happens when land sits barely above the rising edge of the sea. A country only 8 feet above disaster. Some countries are defined by towering mountain ranges or vast plains, but the Maldives is shaped by the opposite extreme. This chain of islands in the Indian Ocean is one of the lowest nations on Earth, with its highest natural point rising only a few meters above sea level. That geography makes the country exceptionally vulnerable to even modest sea level rise, a risk already accelerated, with global oceans now climbing more than 3 millimeters per year on average since the 1990s. For a nation made almost entirely of coral islands, every fraction of that rise matters. The consequences are impossible to ignore. Shorelines are steadily eroding, shallow islands experience more frequent flooding, and once-wide beaches have begun to vanish into the sea. For Maldivians, the change goes beyond geography, it is about survival. By 2025, both citizens and government leaders openly acknowledge that large-scale displacement is a looming reality. National policies now include strategies for relocation alongside adaptation measures, preparing for the possibility that entire communities may need to abandon their ancestral home within this century. Despite the threat, daily life continues. The Maldives remains a global destination for tourism, with its turquoise waters, coral reefs, and resort islands hosting millions of visitors. Yet even this vital industry is under pressure. Coral ecosystems are stressed by warming water and acidification, damaging the very reefs that shield islands from waves. Resorts build seawalls or raise structures above the ground, but no engineering solution can fully replace the natural protections lost as reefs decline. In a country so flat, there are no highlands to offer refuge. Every storm surge or cyclone places the islands at sudden risk. What makes the Maldives' situation striking is the absence of any true safe zone, with projections suggesting sea levels could rise by as much as 2 meters by 2100 under worst-case scenarios. The nation's few meters of elevation provide almost nothing to absorb that change. Add in stronger seasonal storms and rising ocean temperatures, and the outlook becomes even more urgent. Here, geography determines not just borders, but the very question of whether a country can endure at all. And while the Maldives fights to hold back the water, elsewhere geography asserts power through a different extremity, a landscape defined almost entirely by desert. A nation that's 99% desert. Libya is one of the starkest examples of how desert can define an entire country. Almost all of its land is covered by the Sahara, leaving only a tiny fraction suitable for farming. The dominance of sand and rock means geography itself sets limits on how people live, what they grow, and how the economy sustains itself. Where most nations depend on farmland, Libya must rely instead on oases and the resources beneath its barren surface. Agriculture does exist, but only in scattered pockets where underground water reaches the surface. These oases are the lifeline of human settlement, centers where villages form and farming can take root in otherwise unyielding surroundings. Date palms, grains, and a few vegetables grow there, but never in quantities large enough to support the wider population. Life clings to these rare patches of green, just as it has for centuries, while beyond them stretches an environment too hostile to cultivate. Historically, nomadic communities adapted by moving across the desert in search of water and trade, linking oases through caravan routes. Their survival depended on resilience, knowing how to navigate scarcity and endure heat with minimal resources. Modern towns and infrastructure have changed aspects of daily life, but the underlying reality remains. Without the ability to expand farmland, Libya cannot escape the desert's grip on its development. Desertification makes the challenge worse. The Sahara continues to creep southward, erasing what little arable land the country has. Climate change accelerates the pattern: hotter summers, shorter rainy seasons, and soil that fails more easily during droughts. Each year, the risks for farmers grow, and each season brings new pressure to adapt. Where agriculture falters, the economy turns even more to oil. Buried beneath the sand are reserves that generate most of Libya's income. Oil revenues sustain the country, but dependence on a single resource makes it vulnerable to global price swings and technological disruption. Libya's geography is a reminder that some boundaries are fixed by nature. Nearly the whole nation is desert, and fewer options remain with each passing decade. When a landscape is shaped almost entirely by absence, the struggle becomes how to build identity, survival, and growth from what is still possible. And that tension between limits and expression shows up not only in land, but even in the symbols nations choose to represent themselves. The only flags that break the rectangle rule. Among national symbols, flags are expected to follow a nearly universal rule. They come in rectangles. This shape has dominated for centuries, favored because it is simple to stitch, easy to attach to poles, and instantly recognizable across battlefields or embassies. Yet there are two exceptions that stand out against this global norm. Nepal and Bhutan are the only countries whose flags refuse the rectangle, each one using form as a statement of cultural identity. Nepal's design is unmistakable. Instead of a single rectangle, its flag stacks two triangles on top of one another. This choice carries cultural weight, with the triangular shapes tied to the Himalayas and to elements of the nation's traditions. While other countries altered designs for global uniformity, Nepal held to its layered form. In doing so, its flag not only avoids being confused with any other, but also embodies a visual reminder of its heritage. The triangles are more than geometry. They are symbols of how the country defines itself against convention. Bhutan sets itself apart less in shape than in design. Its flag is divided by a jagged line with a dragon stretched across both halves. Where alignment and symmetry dominate most national emblems, Bhutan's banner reflects distinct cultural values. The dragon, fierce and rich in symbolism, connects directly to the country's mythology and history. It conveys protection, spirituality, and strength. By emphasizing one defining figure across a non-traditional pattern, Bhutan signals that meaning on the flag matters as much as the format itself. These two flags share little resemblance to one another, yet both break the rectangle rule with deliberate intent. In a world dominated by conformity in flag design, their differences stand out instantly. The use of shape in Nepal and symbolism in Bhutan demonstrates that national expression can take forms as unique as geography itself. Flags shape perception before a word is spoken, telling stories of identity through color and outline. What begins as deviations in design ultimately remind us that maps and symbols do not always align to predictable patterns. And as with flags, the outlines of nations themselves can take surprising forms, sometimes stretching so far in one direction that balance becomes their defining challenge. A country that stretches but stays narrow. Chile is unique on the world map for its shape as much as its size. Stretching for over 2,500 miles along South America's Pacific edge, it runs nearly the full spine of the continent from Peru in the north to windswept Cape Horn in the south. Yet across that immense length, Chile remains only about 110 miles wide on average. This striking proportion, longer than many cross-country journeys, yet narrower than a morning drive, creates one of the most distinctive national layouts on Earth. The contrast forged by this shape is extraordinary. At the northern end lies the Atacama Desert, one of the driest regions on the planet, where some valleys see rain only once in decades. Travel thousands of miles south, and Patagonia greets you instead, with glaciers tumbling into fjords, icy winds carving the coastline, and vast stretches of tundra. Few countries can contain climates this far apart within a single border, but Chile's length compresses deserts, Mediterranean farmland, mountains, and frozen landscapes into one slender ribbon of territory. This layout imposes challenges as well as diversity. Moving from one end of the country to the other requires several days of travel, with much of the infrastructure tied to narrow corridors between the Pacific coast and the Andes. Roads and rail lines hug valleys or coastal plains because the mountains and deserts leave little usable space. For communities thousands of miles apart, but separated by only a slim strip of land, coordination depends heavily on transport that runs lengthwise through constrained routes. Linking such distant regions demands strategic investment in highways, flights, and ports just to ensure the country stays connected. Managing this geography requires balancing extremes. The wide variety of climates creates opportunities in agriculture, energy, and tourism, but leaves Chile vulnerable to natural pressures, flooding in the center, drought in the north, and seismic risks along much of its length. Its narrow width limits room to expand inland, so development must work within tight geographic bounds. At the same time, its elongated shape allows access to resources across half a continent's worth of latitude. Chile demonstrates how geography can both complicate and enrich a nation, turning shape itself into a defining force. The country's ribbon-thin borders prove that location and proportion can shape everything from climate to transport, underscoring how physical geography is never static, but always influencing how nations function. Geography is never static. It shifts in deserts that expand southward, in glaciers that recede into the sea, and in river deltas where new ground rises year after year. What we see in 2025 proves that every map is only a snapshot of a moving world. Oceans climb higher, rivers redraw boundaries, and cities outpace the infrastructure meant to contain them. Technology steadily updates our coordinates, while climate change and new political alliances reshape the lines we thought were fixed. A map shows today, never promises tomorrow. Share which fact surprised you most in the comments, and subscribe for more explorations of how our planet keeps changing.